Hi students, good evening. Welcome to Ramu's eduhub. Today I explain the topic in the 10th class physics, electricity, electric current. What is electricity? The flow of charges in a conductor is known as electricity. What is the flow of charges? The charges, if any conductor to involving the charges and electrons in a conductor present in the conductor, the current does not flow in a conductor. The electrons or charged particles move randomly and it can flow the conductor. The electrons or charged particles move orderly. Next, the electricity are two types: static electricity, dynamic electricity. The ions are electrons rest in position, then it is known as static electricity. The ions are electrons march in the position, then it is known as dynamic electricity. Electric current, it can flow the material, then the materials are known as good conductors. Electric current does not flow the material, then the materials are known as poor conductors or insulators. Example of the good conductors: silver, copper and all metals. Example of the bad conductors: gases, some other non-metals like wood, coal, etc. Electric current I equal to, it is denoted by letter I equal to Q by T. Per unit charge, per unit charge passes through any conductor per second time is known as electric current. Electric current I equal to Q by T. Electric current I equal to Q by T. Electric current in SI units, ampere. Electric current measured the instrument is ammeter. Next, it can flow the current in electricity. For example, in a conductor A to B, the charged particle, the work done by the charged particle A to B is known as electric potential or potential difference. The potential difference is V is equal to W by Q. V mean voltage. Potential difference also known as voltage. V is equal to W by Q. Per unit charge, the work done in a conductor A to B is known as potential difference. Potential difference is also known as voltage. Potential difference SI units, volt. Is measuring of the instrument, voltmeter. Electric current SI units, ampere. Measuring of the instrument, ammeter. Ammeter is always connecting in series in the electric circuit, and voltmeter is always connecting in parallel in the electric circuit. So, electric potential in any conductor is the positive terminal to negative terminal in the battery. The potential difference is also known as, in the battery is known as EMF, electromotive force, epsilon. Now I will explain Ohm's law. George Simon Ohm, it can any electric circuit in a conductor, the flow of current is directly proportional to the potential difference between the conductor. V is directly proportional to I. V equal to IR. Here R means proportional constant. It is also known as resistance. That what is resistance? That means the flow of current to oppose the flow of current is known as resistance. R equal to V by I. R equal to V by I. SI unit of resistance is known as ohms. Ohms. 1 ohm equal to 1 volt by 1 ampere. The resistance depends on the nature of the conductor. Different materials to changes to the different resistances. For example, the metals are less resistances. Gases are more resistances. The next one, the resistance depends on the temperature. The temperature is increases, then the resistance also increases. The temperature is decreases, the resistance also decreases. The resistance is directly proportional to the length of the conductor. The resistance is directly proportional to the length of the conductor. R is directly proportional to L. The resistance is inversely proportional to the cross section area of the conductor. The resistance is inversely proportional to the cross section area of the conductor. R is inversely proportional to A. R is proportional to L by A. Then R is equal to rho L by A. Here rho means specific resistance or proportional constant or resistivity. Rho equal to RA by L. Rho equal to RA by L. The rho means specific resistance. SI unit of rho is ohm meter. SI unit of rho is ohm meter. The specific resistance in a conductor is more, the flow of current is less. The resistance, the specific resistance depends on the nature of the material, and the different materials are different specific resistances. So all metals are less resistivity, it is flow of current is more. Next one, the reciprocal of resistivity is known as conductivity. The reciprocal of resistivity is known as conductivity. For example, the three resistors are in the series connection. The three resistors are in the series connection. In the end to end, the resistors are connecting the series connection. To complete the electric circuit, the equivalent resistance in the series connection is sum of individual resistances of the resistors. For example, R1, R2, R3 are in the connecting in series connection. The equivalent resistance Rs equal to R1 plus R2 plus R3. For example, 1 ohm, 2 ohms, 3 ohms are connecting in series connection. The equivalent resistance Rs equal to 1 plus 2 plus 3. Then 1 plus 2 plus 3 equal to 6 ohms. In the equivalent resistance, the resistors in the series connection, the sum of individual resistance is equal to the equivalent resistance. In series connection, the equivalent resistance is greater than to highest resistance in the series connection. Next one, the resistors are in the parallel connection. All positive terminals are end with one point and negative terminals are end with another point to circuit are joined. Now in the parallel connection, which one is constant? In parallel connection, voltage is constant. In the parallel connection, the resistances, three resistances are in the parallel connection. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. In a parallel connection, the reciprocal of the equivalent resistance is equal to the sum of the individual reciprocals of the resistances. In parallel connection, R1, R2 are resistances. In equivalent resistance, Rp equal to R1 R2 by R1 plus R2. R1 R2 by R1 plus R2. The series connection is it is not applicable by domestic purpose in our houses, because the series connection in the current, electric current in the single way direction. Our house wiring and the parallel connection, because the parallel connection, the flow of current so many ways. The parallel connection uses less amount of current loss compared to the series connection, because in series connection more resistance, more amount of current is lost over ohm. So in electric circuits, in household electric circuit is compulsory parallel connection connecting the all electrical appliances. Remaining topics are explained on Monday. Thanks for watching. Please subscribe Ramu's eduhub.